Hello students, welcome to Narayan PU College online classes. So last class we have discussed about the reactions of phenols, and previous we had already completed the reactions of alcohols also. And roughly I have written here what we have discussed in the previous, and I have given in the form of flow chart. So the first one is here alcohol. I have taken mainly primary alcohols here. Yeah. So whenever we require secondary and tertiary alcohol, we will discuss here also. The first one you see, I have taken here primary alcohol, and first reaction of alcohol with the sodium, you will get the sodium alkoxide. I have already mentioned. And alcohol shows two types of reactions. One is reactions involving the cleavage of OH bond. These are OH bonds. And remaining some reactions are there, cleavage of CO bond. All together I have written here. So the first one here with the sodium alkoxide, alcohol plus acids in the presence of acidic medium, you will get the ester. What is the compound? This is ester. In the same way, acylation. So again you will get here ester. Yeah. So in this one, HCl and ZnCl, we already know low-cost reagent. We have already discussed. And primary alcohols react with the low-cost reagent and gives the primary alkyl halides. And secondary alcohol, if you take secondary alkyl halide, and tertiary, you will get tertiary alkyl halides. And we have already discussed how to distinguish the primary, secondary, and tertiary alcohols by using low-cost reagent that we have already studied. In the similar way, HBr instead of chlorine, you will get the bromine, and SOCl2, I already said this is a Darjan's process. And in this one, SO2 and Cl2 gases will be formed, so that's why we can prepare alkyl halides, pure alkyl halides by using this Darjan's method. That also we have completed. And next one, dehydration of alcohol in presence of acidic medium. So you will get the alkenes mechanism also we have discussed, and very important that for the PU examination I already said here. And next one is oxidation. Oxidation means if you take the powerful oxidizing agents, primary alcohols are converted into aldehydes, and further it is oxidized to carboxylic acid. It will not stop at aldehyde stage. Directly it will be primary alcohols are converted into acids with the equal number of carbon atom with the original alcohol. In the same way, secondary alcohol I have taken. When secondary alcohol oxidized, it will be converted into first aldehyde, and after then also converted into acids. But that acids will have the lesser number of carbon atoms than the original alcohol. Tertiary alcohol. Tertiary alcohol do not undergo oxidation easily, but if you use strong oxidizing agent like concentrate H2SO4, concentrate H2SO4 can act as a dehydrating agent. In the first step, dehydration takes place, alkene you will get it, alkene further oxidized into ketones and carboxylic acid that we have already discussed. If you want to stop the reaction at the aldehyde stage, you have to use the mainly PCC and PDC that we have discussed here. Next one is oxidation with the copper also we have discussed, and with the copper you will get the aldehyde. Primary alcohol if I take aldehyde, secondary alcohol if I take ketones, tertiary alcohol if I take, and tertiary alcohol will not undergo oxidation, so that's why dehydration takes place. And primary secondary alcohol dehydrogenation. Primary alcohols are converted into aldehyde, secondary alcohol converted into ketones, dehydrogenation. But tertiary alcohol with the copper at 573 Kelvin, it gives the alkene as a product. And these are the reactions of what it is here, alcohol. In the next, we will discuss reactions of phenols. So next one, reactions of phenol. Reactions of alcohols we have discussed already. Now reactions of phenols. Clear? So now in this one, we have already discussed. The first one is nitration with the dilute HNO3. You will get the orthonitrophenol and paranitrophenol, which are separated by steam distillation. We have already discussed. And with concentrate HNO3, you will get the compound is picric acid. You will get the compound is what it is, picric acid. And you know high yield of picric acid, how to prepare, we have already discussed. First you have to do the sulfonation, and after then nitration, that I have not written here. So next one is bromination. Bromination, orthobromo and parabromophenol. and bromination in water, you know, 2,4,6 tribromo phenol. And next, this reaction is coal-based reaction. Which reaction it is? Coal-based. We have already discussed. And you know, in the coal-based reaction, first phenol, in the first step, phenol is treated with the NaOH, and after that with the electrophile carbon dioxide, followed by hydration, you will get the, you know, salicylic acid. And this reaction is Reimer-Tiemann reaction. Clear? So in this one, first chloroform NaOH, followed by NaOH and hydrolysis, you will get the salicylaldehyde. This is salicylaldehyde. Clear? And the next one is with the zinc. With the zinc, you know, and benzene plus ZNO will be formed. And the next one is oxidation with the K2Cr2O7 with the dilute H2SO4, and phenols are oxidized to hydroquinones. So these are about the reactions of all reactions together we put here, and you see, then you will get the clarity on the reactions of phenol. Yeah. Next one is, we have completed till now alcohols and phenols, and the last topic is ethers. So the chapter heading already know alcohol, phenols and ethers. Up to the alcohol and phenols we have completed, and the last part is here ethers. And ethers, first we will discuss about the preparation of ethers, and then the first one is preparation and dehydration of alcohol. And this word, this sentence, somewhere we have heard, right? So where it is? So you know, dehydration of alcohol, acid catalyzed dehydration of alcohol, and the preparation of alkenes. Yeah, alkenes we prepared. So what is that one? And you know, dehydration of alcohols mainly takes place in presence of protic acids like a concentrate H2SO4 and concentrate H3PO4. Clear? And actually, and dehydration takes place, and here the reaction dehydration of alcohol is a temperature dependent. It's depend upon temperature. Clear? And you know, the first previous we have already discussed, ethanol we have taken CH3CH2OH, and it is concentrate H2SO4, and what we here we maintain 443 Kelvin. So what is the product we got there? And we got the product is CH2CH2 plus H2. Water molecule is removed or not? Yes. So here you see water molecule is removed within the molecule. One hydrogen from here and OH is from this carbon. H and OH is removed and you got the double bond here. And this we will call as intramolecular dehydration. Intramolecular dehydration means the dehydration is taken place within the molecule. That we will call as intramolecular dehydration. Yeah? And if the same molecule I will take CH2OH, now what I will do, I maintain here concentrate H2SO4, same catalyst I will use, but I will maintain 410 Kelvin. See here, when I take the 410 Kelvin and when I decrease the temperature, then what happened here, you will get the compound is ethers, CH3CH2 and CH2, CH3 plus here H2. You know, concentrate H2SO4, and it is dehydration, removal of which one? Water, but the product is different here. You have to take here two molecules. So how it is forming, you see? And CH3, CH2OH plus, and another one molecule you take, and CH2, CH3, then heat it at 410 Kelvin, then you will get the compound is C2H5O and C2H5 plus what is it? H2. This is only. Okay. Yeah. Means, and take the alcohol, maintain the 410 Kelvin temperature, then here also dehydration takes place. But which dehydration here? Intermolecular dehydration. Intermolecular dehydration. This is. Whenever intermolecular dehydration takes place, ethers are the product, and this is the preparation of which one here? Ethers. Okay, and a very important point you have to remember. You have to mainly take the primary alcohols here, and you have to maintain the low temperature. If you maintain here, if you take the secondary alcohol, and there is a chance of formation of some other products, dehydration may take place. Clear? So what is that? And I will discuss. And this is the main preparation. And here alkene. And again, suppose if you take CH3, CH2OH, and take here concentrate H2SO4, maintain 110 degrees centigrade. 110 means it is 2383 Kelvin. Then you will get the compound is CH3CH2 twice SO4, dimethyl sulfate. See, and here also what happens? H2O remove. All these reactions are which reactions? Dehydration reactions only. Here also water molecule removed. In this case also water molecule removed, and in this case also water molecule removed. Clear? All are dehydration, but this dehydration, which product it form, it depends upon the temperature. So that's why dehydration of alcohol is a temperature dependent reaction. So we need ethers. So that's why we have to take the second reaction. Here you see simple H2. Here substitution takes place, and instead of 2 hydrogen, ethyl groups, 2 ethyl group will be added. Here H2 and 2 OH will be left here. You will get 2 H2. This is dehydration, and also mechanism they have given here in the NCERT textbook. For this, how to form the ethers. Yeah. So ethers, what the reaction I have taken? This is our main reaction. CH3 CH2OH. How many moles I have to take? 2 moles. And what is the reagent I have to take? CH2SO4. Clear? Then you have to maintain 410 Kelvin. Then what the product I will get? I will get CH3 CH2O CH2 CH3. Clear? So this is you have to see here dimethyl ether forming, and plus what you will get here? You will get the compound is H2. Clear it is? Now, what is the mechanism for this one? What is the mechanism? If you see the mechanism here. Clear? So, in this case, what happened? First of all, this mechanism, formation of ethers from the alcohol, involves mainly three steps. In the first step, this is step 1. Clear? It is there in the NCERT textbook, you can see. Step 1, first one, what happened here? Protonation of alcohol. Protonation of alcohol. Protonation of which one here? Alcohol. Clear? Means why? Because alcohol we have taken. We taken here which one? Acidic medium. Acidic medium means what will happen here? First of all, protonation of alcohol takes place. OH plus here which one? H plus. You know, it is electron deficient and it is electron rich. It donates electrons to electron deficient, that is H plus, and make a bond. And then what the compound you will get? CH3, CH2, and OH and H, and oxygen is losing electron. So that's why it was with charge, positive charge. And this is the first step. And second step, what is the step 2? In the step 2, attack of nucleophile. What it is? Attack of a nucleophile. Attack of nucleophile on protonated alcohol. On protonated alcohol. On which one here? Protonated alcohol. Clear? So what happened here? And this follows Sn2 mechanism. This step follows which mechanism here? Sn2 mechanism. Important. What happened you see? You know alcohol CH3, CH2OH. We have taken how many alcohols here? 2 moles of alcohol. 1 mole is protonated, another alcohol is free. So here CH3, CH2, this is the protonated alcohol. So that's why what will happen here? Nucleophile, this is positive charge present here. When it is positive charge on the oxygen become very unstable. It take the electron from the which one? Carbon. when it is taking electron from the carbon, carbon acquires which charge? Positive charge. So that's why here electron deficient and here electron rich. So how we will write in one step? Attack here, then and this bond electron will shift towards the oxygen. Then what will happen? You see, you will get the compound is CH3, CH2, OH, and this O is added to CH2 here, CH2, and that CH2 is added to the CH3. So oxygen is giving electron, so it acquires positive charge. That's what we will get here, H2. That is the which mechanism it follows? Sn2. Sn2 means what it is? You know, nucleophile attacks from the backside. Clear it is? Now this is step 2, and last one is step 3. Common step this is. So previous we have discussed in the first step is almost equal with the dehydration of alcohols. Yeah, and step 3, what will happen? Here on the oxygen there is a positive charge. You know, on the oxygen if the positive charge is, it is very unstable, so it gains the electrons from nearby. So it takes the electrons. Deprotonation. Deprotonation. Next step is deprotonation. That is CH3, CH2, OH, and here positive charge, and CH2, CH3. Then what happened here? You see, and this is proton. It takes the electrons from the hydrogen, and the hydrogen on the oxygen negative charge will come. Already oxygen is having positive charge, so that's why, and the charge will be neutralized and the H+ will be removed. This is how, and here intramolecular dehydration takes place when we use the concentrate H2SO4 and maintaining the low temperature. Okay. Reactivity of dehydration of alcohols to form ethers. Okay. Just now only we have discussed about the mechanism of dehydration of ethers to dehydration of alcohols to form ethers. But I already mentioned when we start the preparation of ethers by the dehydration, primary alcohols are easily involved in the dehydration to form ethers compared to the secondary and tertiary alcohols. Yeah, and also we have to maintain here low temperature. If you maintain high temperature, you already know dehydration, high temperature, you will get the alkenes as a product. So in this case, what happened? And if you take secondary alcohol, suppose I will take secondary alcohol CH and CH3OH. I will take the 2 moles here, same, and concentrate H2SO4, maintain the 410 Kelvin temperature here. So what you will get in this case is the major product you will get when you take the secondary and tertiary alcohols are alkenes. CH3 and CH double bond CH2 plus, and you will get and CH3 and O and CH3 and CH3. This is major product you will get, and ether is the minor product. Ether is the minor product. You know why? Because in this case what happened? You know CH3, and this is the secondary. Secondary means bulky groups here. See now, if it forms ether, and here bulky group and bulky group, two bulky groups are very close to each other, so that's why, and ether become unstable. If unstable, it forms in a small quantity. So that's why, due to that, and these involved, this secondary and tertiary alcohols involved in the which one? Mainly dehydration. Dehydration and forms which one here? Alkene, not the ether. Ether also forms, but very less amount. And this follows Sn1 mechanism. Only primary alcohol follow Sn2 mechanism. Secondary and tertiary, if I take secondary, and exclusively it will form alkenes. Same condition, and you will get the compound is here, and the CH2, and here CH3 plus H2. There is no formation of ether. Why? Because secondary only so much bulky. If tertiary comes, the ether is very unstable. So that's why, what is the reactivity of dehydration of alcohols to form ethers? The first one is here. Primary alcohols involves in the dehydration very fast compared to the secondary alcohols, and here 100% only alkene. You will not get any ether. Secondary alcohol, and last one is which one? Tertiary alcohol. Yeah. So that's why primary alcohols involved in the dehydration very fast to form which one? Ethers. Yeah. And second condition, what you have to maintain? You have to maintain low temperature. If you maintain high temperature, alkene is the major product. Yeah. So this is the reactivity R of which one here? Alcohols to form ethers. Yeah. And the next one is very important reaction, Williamson's reaction. So what is Williamson's reaction? We have already discussed Williamson's reaction in haloalkanes and halohenes. Have you remembered that Williamson's reaction? Remember that now? If you remember, once you see what the product we will get in the Williamson's reaction, and ethers are the product in the Williamson's reaction. Clear? And roughly I will write here what is the Williamson's reaction. Next one is very important for your PU examination and also for completing. Yeah. So next one is Williamson's reaction, or sometimes they will give synthesis also. Williamson synthesis, or you can simply say Williamson's reaction. So what is the Williamson's reaction? You know that alkyl halide react with the sodium or potassium alkoxides. Yeah, and forms here ethers. R O double bond R plus what you will get here? NaX. This is. So what are the product here? What is this? Is alkyl halide. This is which one? Alkyl halide. And this is what? Sodium alkoxide. Sodium alkoxide. And ethanol solvent you can use here and heat it. Then what the compound you will get here? You will get the compound is ethers. Yeah. And very important another one is here the formation of ethers from the alkyl chloride, alkyl halides and sodium alkoxide follows. Which simply I can write here Williamson's reaction. Very important this is follows Sn1 mechanism. It follows Sn1 mechanism. Very important this is. It follows which mechanism here? Sn1 mechanism. Now just simply I will take one example, and after that we will go for some other examples also. First one I will write here methyl bromide. Simple example I am taking, and here sodium ethoxide. Sodium ethoxide. Okay, and then what the compound we will get to see here. The compound we will get in this case is and CH3 and OC2H5 plus NaBr. Okay, and also this is the third point I can say. By using Williamson synthesis, we can prepare the all type of ethers. Means we can prepare the symmetrical ethers and can also be prepared the unsymmetrical ethers. Clear? I have taken here one is CH3Br and another one. You see, it is an unsymmetrical ether. If I take here simple example CH3Br and CH3ONa, then what the compound I will get? CH3OCH3 and plus NaBr. And this is which one? Unsymmetrical ether, and this is what it is, symmetrical ether. Okay? But by using dehydration of alcohols, we can prepare only the symmetrical ethers. Unsymmetrical ethers we cannot prepare. We can prepare, but mixture will come. One question is there in the answer test book. We will do that one also. But by using Williamson's reaction, we can prepare all types of ethers, symmetrical ethers and also unsymmetrical ethers. That is the third point. And here, third point I will write here by using Williamson's reaction, symmetrical and unsymmetrical ethers can be prepared. can be prepared. Clear? So this is the point. Now we have some questions here. Remember, I already mentioned whenever Williamson's reaction takes place, it follows Sn2 mechanism. Sn2 mechanism means, you know, we have discussed about Sn1 and Sn2. Sn2 mechanism is very fast if the alkyl halide is a primary. Means best with the primary alkyl halides. Williamson's reaction takes place very easily with the primary alkyl halide. Suppose I will write one example here. CH3 and here CH3, and you know sodium alkoxide I have taken, and now CH3 BRR CH3Cl. That is your ratio. Clear? Now what do you have to get? You have to get the ethers. Ethers means it follows which mechanism? Sn2. You know when this bond breaks, and here this is a negative charge and this is a positive charge. It is a nucleophile. Tertiary, it is sodium tertiary butoxide. This is tertiary butoxide. Sodium tertiary butoxide. Yeah. Now this is a nucleophile, and now nucleophile has to attack on where? Alkyl halide, and it will attack from the which side? Back side, because it is a Sn2 mechanism. It follows Sn2 mechanism. So that's why what the compound you will get? CH3, and here also you will get the CH3 and OCH3 plus it is Na plus, and it will be removed as a Br minus, and bond will be there, sodium bromide. Now we can easily prepare here unsymmetrical ether, tertiary butyl methyl ether. Now I will write the same reaction. To prepare this, I will write another way. So what that one is, I will write CH3ONA, sodium ethoxide. Now I will write alkyl halide. I will take as a tertiary alkyl halide. This is which alkyl halide? Primary alkyl halide. Now what I have taken here? Tertiary alkyl halide. Tertiary alkyl halide. Will ether formation takes place? Ethers will be formed? No, ethers cannot be formed here in this reaction. Why? Because you know it is a which one? O minus and Na plus, and CH3O minus is a nucleophile. Now it has to attack on where? Tertiary carbon, but you know, and tertiary tertiary alkyl halides will not involved in the Sn2 mechanism. Means here you know very bulky groups are there, and these bulky groups cannot allow the nucleophile to attack on the carbon attached chlorine. Clear? Chlorine attached carbon. Yeah. So that's why this reaction will not take place. It will take place, but ethers will not form. Ethers will not form. Ethers will not form. So what is the product formed here is, you know that CH3O minus and Na plus, and plus CH3 and CH3 Cl is there. You know this is nucleophile. All nucleophile can act as a basis also. And this here nucleophile character, it will not show the nucleophile character here. Why? Because as a nucleophile it cannot attack on the carbon. So that's why it will show the double character now. Which character? Basic character. Now it act as a base. When it act as a base, you know it involved in the what it is? Elimination reaction. Base always accept the proton. Yeah. So what will happen here? Elimination reaction takes place, and CH2H. Yeah. And this is it accept the proton. Base always accept the proton. Now this bond will come here. Chlorine will be removed. Elimination reaction takes place. So that's why what the product you will get? CH3 C double bond CH2 CH3 plus you know CH3OH, and plus you will get here NaCl. So ethers cannot be prepared if you take the alkyl halide is a tertiary. If you take alkyl halide is a primary, then formation of ethers takes place very easily. So that's why, and an alkyl halide must be primary. Must be means if primary is there, reaction takes place very fast. Now we have discussed about the Williamson's reaction. Now phenols can also be converted into ethers by using Williamson's reaction. Yeah. Now, first one I will take here. Phenol means I will take phenoxide ion, sodium phenoxide. What it is here? Sodium phenoxide. Sodium phenoxide plus I will take here methyl chloride. What I will take here? Methyl chloride. Then what happened here? You know, Sn1 reaction takes place, and here O minus Sn2 reaction takes place here. Attack and chlorine will be removed. NaCl will be removed. Then what the compound you will get? You will get the, and here OCH3, phenyl methyl ether. What it is here? Phenyl methyl ether plus NaCl. Clear? So this is the how to prepare, how to convert the phenol into ethers. What is the name of this compound? Anisole. What is the name of this compound here? Anisole. Clear? Now, can I do this reaction in the different way? Means, suppose if I take alkoxide is a methyl, CH3ONa, sodium methoxide, and plus I will take chlorobenzene. Will the reaction takes place? Will the reaction takes place? What is the actual reaction here? It is minus and plus. Where it has to attack? Here and chlorine should be removed. But you know we have already studied in the haloalkanes and the haloarenes. You know haloarenes are very less reactive towards the nucleophilic substitution reaction. Nucleophile is substituted here. Why? Because this single bond, chlorine and carbon is not a single bond. It is a partial double bond character. It is a double bond, so that's why partial double bond. So that's why we cannot easily break this carbon and Cl bond. So that's why nucleophile cannot easily attack. So that's why whenever, and here they have given chlorobenzene or halobenzene, they never involved in the which reaction? Williamson's reaction. So you will get here no reaction. Clear? So that's why to prepare anisole, and you have to choose methyl chloride and sodium phenoxide. You should not choose here and methyl sodium methoxide and chlorobenzene. That is I want to say. So whenever whatever it may be alkoxide with the benzene. Suppose I will write, can we prepare, and this is the compound, and O, and here another one is O. Diphenyl ether by using Williamson's reaction? No, we never prepare. We cannot prepare this one. Why? Because to prepare this one, and one of the sodium alkoxide and another should be halobenzene. So what it is? I have to take here same reaction, and O Na, and plus another one. What I have to take here? Chlorine. I have to take chlorine here. So this is, you know, partial double bond character, haloalkanes. It cannot be involved in the nucleophilic substitution reaction. So no, this compound, this reaction cannot be happening. So that's why, and this is the Williamson reaction. And also you see in the NCERT textbook one question they have given. So what the question they have given is, see the question number 11.6. Question number 11.6. See here, the following is not a appropriate reaction for the preparation of tertiary butyl ethyl ether. So what the reaction they have given? C2H5 ONa plus, and here tertiary butyl chloride. I have already discussed this one. CH3 and Cl, and you will get the compound is, and here tertiary butyl and methyl or ethyl ether. C2H5. This is the reaction. So there is saying the following is not a appropriate reaction for the preparation of this compound. It is not a convenient method to prepare this product. So they are asking what would be the major product of this reaction, and write the suitable reaction for the preparation of tertiary butyl ethyl ether. Yeah, so they are asking, it is not a, they are saying it is not a convenient method or best method to prepare this, and if it is not formed, what will form in this reaction, and what is the method to prepare and tertiary butyl ethyl, you know, ether. So first one you already know, it is a tertiary alkyl halide is there. Tertiary alkyl halide is there means it will not participate in the Williamson's reaction. So that's why ethers you will not get. So that's why what you will get here? You will get the compound is alkenes. I already mentioned. It acts as a, here it acts as a base, and base what it will do? Accept the proton, so elimination reaction takes place. When base is there, elimination reaction. Elimination reaction means what happened here? And H and Cl remove, then what the compound you will get? CH3, CH2, and here CH3. 2-methyl propene is the major product. 2-methyl propene is the major product in this one. Now this is the first one. Second one, what they are asking, and what is the convenient method to prepare this tertiary butyl and ethyl ether? And ethers are mainly prepared by the Williamson's reaction. Williamson's reaction means you have to one reactant should be alkyl halide and another one is sodium alkoxide. And in the Williamson's reaction for Sn1 mechanism, so that's why. And you have to take the alkyl halide is a less bulky. Which one is less bulky here? C2H5 is less bulky and this is a bulky group. So that's why if you take the reaction is CH3, CH3 and CH3ONA, sodium tertiary hydroxide, and now if you take here C2H5Cl, then the reaction takes place here. So what the compound you have right here? CH3, CH2Cl. Then what happened here? Negative charge and Sn2 mechanism, and the NaCl will be mixed, Cl minus will be removed, it will be reacted with the NaCl. So that's why CH3 and CH3 and OC2H5 will be formed in this reaction, NaCl. So this is the convenient one. You should not take tertiary alkyl. Clear? Next one is physical properties of ethers. And physical properties of ethers, you already know. Here in the ethers, there is a bond, you can say ROR. This is the compound. Clear? These are the ethers. You know that the bond between the carbon, alkyl group means carbon and oxygen is slightly polar. It is a slightly polar. Clear? So that's why. And if any molecule is polar, and the polarity is measured by dipole moment. So that's why the molecule is, ether molecule is slightly polar. So that's why it will have dipole moment. So that dipole, it will have some dipole moment. Dipole moment. So what is the value? Is almost 1.15, very less. 1.3. This is the value. Yeah? So 1.15 to 1.3, and this is the dipole moment value of this one here, ethers. Yeah? And you know that, and first we will discuss what are the boiling points here and solubility, then we will go for the reactions. And in the first one, we have to discuss boiling points. Yeah? So first I will compare the boiling points of alcohols and ethers. Yeah, you know that if you compare the alcohols and ethers, yeah, alcohols and ethers are, and suppose I write here OH simply. Yeah, so now you take here alcohol, and this is alcohol, and it is a ether. Alcohol will have high boiling points than the ethers. So you already know why it is, because alcohols I already mentioned, and they can form the intermolecular hydrogen bondings. So due to the intermolecular hydrogen bonds existed in the alcohol, so alcohol will have high boiling points than the ethers. Clear? Now I will compare here boiling points of ethers to alkane. This is important. Sometimes they are asking in the competitive examination. And if I compare alcohol ethers to alkanes, RCH2R, with the comparable masses. Clear? Remember here, and ethers with 3 carbon atoms. 3 carbon atoms, or you can say ethers up to the 3 carbon atoms will have greater boiling points than the alkanes. Alkanes with the comparable masses. With the comparable masses. Means what it is? I will say one example here. Suppose CH3 and C2H5. C2H5. Ethyl, methyl, ether. I will take alkane here is CH3, CH2, CH2 and CH3. Comparable masses. Instead of carbon, oxygen here and one carbon is there. One carbon is there. Clear? So if you compare here, ethers have high boiling points than the what is up to which carbon here? Third carbon only. Clear? And if ethers having the greater than 3 carbon atoms, then automatically boiling points will be reversed. Means ethers having more than 3 carbon atoms, more than 3 carbon atoms, then the boiling point order is, and alkane has greater boiling points than ethers. Then this one here, ethers. And simple, I will write here one compound, and CH3 and CH2 3 times and CH3. This is pentane. Now I will write here and C2H5 and both C2H5. You know, this is N-pentane and it is diethyl ether. So actually, and ether is somewhat polar than the alkanes. It should have greater boiling points slightly, but that is up to the third carbon. So one time, and they have given this compound diethyl ether, and here pentane they have given in the competitive examination. The mains examination, alcohol they have given, and here alkyl halide, ethers means they have given, you know, diethyl ether and pentane. They have asked here to write the boiling point order. Then you have to write in this way. Alkanes will have greater high boiling points than the ethers if carbon atoms are more than 3. Here you see 4 carbon atoms. Okay. So here I have to write 5 here. Why? Because here oxygen is there. Comparable masses I have to consider. So that's why I have here 1 carbon for alkanes. And the next one is solubility. This is about the which one here? Boiling points. So if I write here one example, they have given N-pentane, they have given CH3, CH2 3 times, and here CH3 3, 4, 5, and another one they have given here C2H5O and C2H5. Next one they have given here CH3, CH2, CH2OH. This is the compound 1, 2, 3, 4, 5. Yes, this is the compound. Cancel the textbook they have given. So write the boiling points are here. Boiling points are 1 and 2 and 3. Boiling point orders they are asked to write here. First one, you know, alkane, ether, alcohol. Alcohol will have high boiling points because of intermolecular hydrogen bond 3 greater than. Now you see 1 and 2, ether. Ether is having how many carbons here? Greater than 3. Greater than 3 means alkanes will have high boiling points than the ether. So 1 and next one is 2. This is. And the next concept is here solubility. Next concept is solubility. Clear? Lower ethers up to the 3 carbon atoms. You can say lower ethers up to 3 carbon atoms. 3 carbon atoms are highly soluble in water. Highly soluble in water. Because they have almost solubility up to the 3 carbon atoms, they have the solubility comparable with the alcohols. But after 3 carbon, ethers having more than 3 carbon atoms, more than 3 carbon atoms, clear? And those compound ethers will have less, means insoluble. You can say insoluble in water. Yeah? and you already know that. If you take the ethers, this is the formula of ether. Will have the how many lone pairs here? 2 lone pairs. So that's why they can form the here hydrogen bonds, and they donate the lone pair of electrons to hydrogen and form hydrogen bonding. And they can form the hydrogen bonding when the alkyl groups are very small. If the chain length of alkyl groups increases, then what happens? This length increases, these groups will not allow the oxygen. Bulky groups will be present here. When bulky groups are coming here, and these bulky groups will not allow the oxygen to form a hydrogen bond with the water molecule. So that's why, as the number of carbon atoms increases in the ethers, the solubility decreases. Up to the third carbon, the ethers are soluble in water, but ethers having more than 3 carbon atoms, they are very less soluble, you can say insoluble in water. And here hydrogen, you see, ethers can form the hydrogen bonds up to the how many carbons here? 3 carbons. 3 carbons, total carbon group should be 3. Here suppose 1 and here 1, 2. Here 1 and here 2 carbons, 3. That is. So this is the solubility and boiling points of ethers. So next physical property we have already completed. So now chemical reactions of ethers. Okay? You know, ethers are almost inert compounds. Ethers are, and you know, relatively they are very inert. But if you maintain some drastic conditions, they can involve in the reactions also. Okay? They are very, you know, if you maintain the normal conditions, they are very stable to acids, bases, and you know, reducing agents, all. So that's why you have to maintain some conditions. Then they involve in the 2 types of reactions. One is reactions involving cleavage of you know, CO bond, means carbon and ether bond. This is. And another one is reactions of ethereal oxygen. Reactions of ethereal oxygen means in the reactions ethereal oxygen will be involved in the reaction. So these are 2 types. So first we will discuss about the first one, that is reactions involving the cleavage of CO bond in ethers. Clear? So now first one reaction is, that is CO bond, and reaction with halogen acids. A reaction with halogen acids. Okay? So this is very important concept. You have to remember. You have to concentrate. Okay? And first one, if you take suppose alcohol and treated this one with the HX. Alcohol on ether. Take the ether, symmetrical ether, then take the HX here, and then you will get one of the bonds, CO bond will break, and if it is symmetrical ether, this CO bond can be break at anywhere. It can be break here or it can be breakable here. So that's why, and if this bond breaks, add H to the one oxygen and another X will be to the another carbon. So that's why you will get ROH plus, you will get here RX. Yeah? What are the products here? Alcohols and alkyl halides. Alcohols and alkyl halides. Okay? And simple example, when it is a symmetrical ethers only, it is a which ether? I will write here. Symmetrical ethers. But unsymmetrical ethers means it totally changes. Okay? Now you see, if I take simple example, CH3COCH3 plus HCl. Plus what here? HCl. Yeah? Then what happened? You see, break any bond where both are same. If I break this bond H and here I, then what I will get here? CH3OH plus CH3I. If I take suppose C2H5 and OC2H5 plus HI. HI is more reactive, so it is preferable, and H and here I. then what you will get? C2H5OH plus C2H5I. Yes, here. Yeah? And now this is the first one. And the second one, same with the symmetrical ether. This is I. Yeah? With the symmetrical ether, I will take ROR plus HI. This is excess amount I will take. So take the excess amount. When you take the excess amount, then you will get the product is 2 moles of alkyl halides plus H2. You know, same. If you take HI, first what you will get? Alcohol, and after that alkyl halide. You are taking excess amount, so that's why what alcohol is formed here, again reacted with the HI, these alcohols are converted into this is alcohol, again reacted with the, and the excess amount of the HI, you know, H2 will be removed, you will get the which compound? Ri plus H2. Already one Ri is formed, and this alcohol also converted into which one? Ri, so you will get the 2 moles of Ri. That is important. If they give excess amount, the products are alkyl halides only. If they give limited amount, means HX, they don't mention here excess, then it is a, one is alcohol and another one is alkyl halides. Clear? Simplify it, say example, and CH3 and plus HI. If they mention here excess or sometimes 2 moles, then you will get the 2 moles of CH3I plus what it is H2. So when symmetrical ethers are there, and you can break the bond at anywhere and add the HI. But the problem comes with unsymmetrical ethers. Unsymmetrical ethers. Clear? And now before going to that, simply I will roughly give here. Whenever there are a primary and a secondary alkyl groups are there in ether, alkyl groups, then they follow the Sn2 mechanism. Means the product is formed by the Sn2 mechanism. If any one of the alkyl group is a tertiary alkyl group, the product is formed by the Sn1 mechanism. This you have to remember. Clear? If one is means if the groups are either both are primary or one is primary and another one is secondary, then they follow the which mechanism? Sn2 mechanism. Sn2 mechanism means the nucleophile attack always to the smaller group only. Clear? That is important. Clear? So now this you remember, then we will discuss here some concepts. What are those? And here I will write. And first one example I will give. You can easily understand now. Unsymmetrical ether I will write. One is CH3 and O, and another one is C2H5. Another one is what is C2H5, and I will write here HI. I will write here which one here? HI. Clear? Now, and here first of all I will write the mechanism. What is the mechanism? Because they have given in the answer textbook. So how the reaction takes place. Yeah, and you know, first of all, what the product you will get in this case is CH3I plus C2H5OH. This is the compound you will get. And how you will get? And first mechanism you have to write. See the mechanism. If you see the mechanism here, you know CH3 and O and C2H5. And HI means first quantity. It gives the H plus and the I minus. You know it is electron deficient. It is electron rich. Electron rich will react with the electron deficient only. It is electron rich. Electron rich will not take place. So that's why you know oxygen always it donates electrons to deficient. So H plus. Then what the compound you will get? CH3 and O plus, and here H and C2H5. So proton is added, means here it donates the pair of electrons, and you get the here oxonium ion. It is a oxonium ion. Now in the next step, which one is left here? Plus I minus is there. I minus attack takes place. Clear? So now you see Here CH3 and here plus H and C2H5 plus which one is there here? I minus. The groups are here which group? Methyl group and here which group? Methyl group. You know these are primary groups only, primary alkyl groups. But you know I minus it involves Sn2 mechanism. Sn2 mechanism is nucleophile. Attack at the smaller group only. And here CH3 and CH5. Which one is smaller group? CH3. So it attack here. This bond electron. This bond will break now. So that's why you will get the compound is CH3I and C2H5 and it is OH. That is only after. You should not write here C2H5I and CH3OH. Yeah. So this is the mechanism. Means remember you will get whenever the ether is having the primary alkyl group and secondary alkyl group, and you will get the alkyl halide always with the smaller alkyl group only. See here CH3 and CH5. CH3 smaller group, always iodine means alkyl iodide will be formed from the smaller group only. Okay? And this is whenever any group is present, like suppose I will write another example here. And CH3, CH2 and O and CH, CH3, CH3. I have taken here HI. I am not taking excess amount here. Okay? Excess amount means this alcohol also will be converted into iodine. So now directly you say what is the product here? You know which one is smaller group? This is smaller group, so that's why iodide will be formed with the smaller group only. Directly you can write CH3 and CH2I plus what it is there. And here CH3 and here you will get the compound is CH3 and CHOH and CH3. If suppose both are secondary only, CH3, CH3 and O and CH3 and CH3, this is symmetrical. So that's why definitely you will get one is alcohol, anywhere you can take it. You will get the compound is and isopropyl alcohol and another one is isopropyl chloride. This is CH3. Yeah? But the problem comes whenever any one of the alkyl group is a tertiary. Any one of the alkyl group is a which one? Tertiary. Suppose I will write this is CH3, CH3 and CH3. Suppose O and CH3. Now I added here HI. Okay. Then in this case, and what happened? And this bond, where the bond breaks means, and first of all, protonation takes place, and this bond will break. Why? Because, and here, if your bond breaks, you will get the tertiary carbocation, and which is, very stable. So that's why I said, whenever any tertiary group is present here, it follows the Sn1 mechanism. Sn1 mechanism means what is the intermediate here? Carbocation is intermediate. So where the bond breaks here, if bond breaks this bond, CO bond, you will get the tertiary carbocation. If this bond breaks, you will get the primary carbocation. Which one is more stable? Tertiary is more stable. So that's why. And this bond will break and you will get the alkyl halide this time with the bulkier group, not with the smaller group. And you will get CH3OH. Clear? So that is the concept here. Whenever there is no tertiary group and simply you write the alkyl iodide with the smaller alkyl group only. But any one of the group is a tertiary, then it follows Sn1 mechanism. Sn1 mechanism means and tertiary butyl, tertiary carbocation will form and I minus will be added here to the positive charge. You will get the tertiary alkyl iodides. Okay? And in the same way, suppose sometimes they will give like this, and here N is sold and treated with the HI. And another important point is here. Whenever the group is a tertiary and benzyl group is present, I forgot to mention there. I have mentioned tertiary alkyl group is there and another one is benzyl. Benzyl group is there. Always they follows which one mechanism? Sn1. They follows Sn1 mechanism. Okay? See now. In this case is there If you see, the bond breaks here. Why? Because if this bond breaks towards A, then what the compound you will get? You see, you will get the CH2 plus and plus CH3O minus. You know, and here benzyl carbocation. You already know that benzyl carbocation is very stable due to the resonance. So that's why it is forms very stable carbocation. So that's why iodide will be added here. Iodide ion. You will get the compound is this is and CH2I plus H will be added here CH3OH. Okay, so this is very important. You have to understand the concept here. The final product will be formed here is CH2I plus CH3OH. Okay, so because when our tertiary group and benzyl group is there, they follow which mechanism here? Sn1. And here which mechanism? Sn1. Sn1 means you have to see the carbocation, not the small group or bigger group. You have to see the carbocation. But here which this follows, this reactions follows which mechanism? Sn2. Sn2 means and the nucleophile will be attacked at the smaller group. What is the nucleophile here? Iodide ion. So that's why alkyl iodides will be formed with the smaller group. Okay.